SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, it's all systems go for NASA's mission to a potentially deadly asteroid. A SpaceX Falcon 9 rocket explodes on the launch pad, and has the alien megastructure star mystery finally been solved? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The final countdown is underway for tomorrow's launch of NASA's OSIRIS-REx spacecraft on a 7-year journey to visit the potentially deadly Near Earth Asteroid 1955 Bennu. Bennu is a dark 492-metre wide, unexplored carbon-rich space rock which passes uncomfortably close to the Earth every 6 years. It's part of the debris trail left over from the formation of the solar system 4.6 billion years ago. However, because Bennu comes close to the Earth, it's classified as a potentially hazardous asteroid. In fact, there's a 1 in 2,500 chance that it will hit the Earth in the 22nd century. On average, an asteroid like Bennu, say half a kilometre wide or more, is expected to impact the Earth about every 130,000 years. So technically, we're already well overdue for the next big one. NASA's Origins Spectral Interpretation, Resource Identification, Security Regolith Explorer spacecraft, or OSIRIS-REx for short, will fly to asteroid Bennu to help astronomers understand these ancient worlds and hopefully find a way of preventing them from slamming into the Earth. OSIRIS-REx will be NASA's first sample return mission to an asteroid. The 2,110-kilogram spacecraft is launching on an Atlas V 401 rocket from Space Launch Complex 41 at the Cape Canaveral Air Force Base in Florida. The launch is slated for 19:05 United States Eastern Daylight Time, Thursday, September 8, with a comfortable 34-day launch window. OSIRIS-REx will orbit the Sun for a year, then use Earth's gravitational field as a gravity-assist slingshot to fling itself to rendezvous with Bennu in August 2018. The spacecraft will use an array of small rocket thrusters to match the asteroid's velocity and begin a year-long study of the pristine space rock, mapping its surface, composition, and physical properties. Bennu's small size and lack of mass makes navigation a particular challenge. You see, the asteroid will be one of the smallest objects ever visited by a planetary spacecraft. Bennu has very little gravity, so little that the pressure of sunlight on OSIRIS-REx will almost equal the force of Bennu's gravity. So in order to stay in orbit, the spacecraft will have to remain within 2.4 kilometres of Bennu. Any further than that, and the pressure from sunlight will slowly push it away from the asteroid. From remote observations, scientists hypothesized that Bennu should contain water and organic or carbon-rich material, but they don't know yet how this material is distributed across the surface. Some of the most interesting sites will be those that offer fresh material, perhaps exposed by an impact, a crack, or plume activity like comets have. And the coldest places on the asteroid should have a higher science value, because that's where organics are likely to be better preserved. To figure this out, the team will look at geological features, mineralogy, chemical composition, and temperature. They'll start by looking for promising sample sites where the spacecraft can drop down to just above the asteroid surface and then lower its robotic arm to collect rock and soil samples. The mission will collect up to 2 kilograms of surface material for return to Earth in 2023 using a detachable capsule. OSIRIS-REx's science instruments include the OSCAM camera suite, a system of 3 cameras to provide global imaging, sample site imaging, and to observe sampling events. Another instrument will be the OLA-A scanning LiDAR, or light detection and ranging laser altimeter. It'll be used to measure the distance between the spacecraft and Bennu's surface, and it will map the shape of the asteroid. The OTI's thermal emission spectrometer will investigate mineral abundances and provide temperature information with observations in the thermal infrared spectrum. Meanwhile, the OVIR's visible and infrared spectrometer is designed to measure visible and infrared light from Bennu to identify mineral and organic material. Finally, there's the Regolith X-ray Imaging Spectrometer, or REXIS. It'll observe the X-ray spectrum to identify chemical elements and their abundances on Bennu's surface. OSIRIS-REx also has two systems of sample collection. There's TAGSAM, the touch-and-go sample acquisition mechanism, basically an articulated robotic arm with a sampler head to gather material from Bennu's surface. And there's the Sample Return Capsule, or SRC, which is fitted with a heat shield and parachutes and will be used to return the asteroid samples back to Earth in 2023. Astronomers believe Bennu is nothing more than a loosely bound collection of boulders, rock and dust known as an asteroid rubble pile. Measurements reveal that Bennu's density is less than that of rock, so scientists think the asteroid may have internal voids. Bennu's also very dark, with a low albedo, reflecting little light. That means just like an asphalt road on a hot day, it absorbs most of the sunlight that hits it, and later radiates this energy away as heat. This radiated heat acts like a sort of slow-moving jet, giving Bennu a tiny push known as the Yarkovsky effect, which gradually changes the asteroid's orbit over time. This Yarkovsky effect causes Bennu to migrate until it encounters a so-called gravitational resonance with the planet Saturn. Regular tugs by this resonance eventually pushes Bennu into the inner solar system, where it has repeated close encounters with both Venus and the Earth. These close encounters are thought to pull apart the rubble pile that is Bennu, turning it inside out and reshaping the asteroid. Astronomers will get accurate measurements of the Yarkovsky effect on Bennu by tracking OSIRIS-REx as it orbits the asteroid. And the spacecraft's designed to measure things that contribute to the Yarkovsky effect, such as composition, energy transport through the surface, temperature and topography. Tilt measurements and thermal information will reveal how the material on the asteroid's surface stores and releases heat. It's thought coarser, rockier grains will absorb more heat from the sun and then give it off slowly during the asteroid's night, while fine grain particles would lose heat very quickly once they're out of direct sunlight. All this should allow astronomers to study how pressure from sunlight influences the path of the asteroid, data which will prove vital when Bennu or another space rock is discovered on a collision course with the Earth. And remember, the one thing scientists agree on is that's not a case of if, but when. In fact, a 2010 dynamical study predicted a series of 8 potential Earth impacts by asteroid Bennu between 2169 and 2199. Astronomers think they may finally have solved the mystery surrounding a weird, erratically flickering and dimming star, whose strange behaviour sparked speculation that it could be our first sign of an advanced alien civilization. The star, named KIC 846285-2, was first detected by NASA's planet-hunting Kepler Space Telescope. However, the observations were so unusual, one scientist jokingly suggested that it could be a hypothetical alien megastructure known as a Dyson sphere. If they exist, Dyson spheres are massive artificial structures large enough to encircle an entire star, harvesting off all its energy to power an advanced civilization. Astronomers now think what they're actually seeing is a new stage of stellar evolution in newly formed stars. KIC 846285-2 is a spectral type F main sequence star, a little bit more massive and a little bit hotter than our Sun. It's located 1,480 light-years away in the constellation Cygnus. Scientists began intensive observations of the star after they began seeing sudden unexplained dips and changes in its luminosity by up to 20% over very short timescales. These changes in brightness were far too radical to be simply attributed to intrinsic variability. A study of 193 nearby stars and 355 similar stars ruled out natural phenomena like giant molecular gas and dust clouds between the Kepler Space Telescope and the KIC 846285-2 system. Whatever was happening, it was only happening around this particular star system and nowhere else. While the Dyson sphere hypothesis was never taken too seriously by anyone except the tabloids, the observations did leave astronomers somewhat mystified. The leading hypothesis, based on a lack of observed infrared light, is that a swarm of cold, dusty cometary fragments in a highly eccentric elliptical orbit were intermittently blocking out the star's light as seen by Kepler. But the problem is that still couldn't explain everything that the astronomers were seeing. They now believe the star is in fact far younger than previously thought. So young that it's still surrounded by coalescing material which Kepler's seeing edge on. They also speculate the stellar system could have a warped inner circumstellar disk of accreting material. Circumstellar disks are ring-shaped accumulations of matter composed of gas, dust, planetesimals, asteroids and collision fragments in orbit around a young star. These disks are the reservoirs of material from which future planets are formed. The new research suggests that new stars with large luminosity dips are likely to include both an outer and an inner circumstellar disk of material. The conclusions are based on a new study of another young star, EPIC 2042-78916, which is displaying very similar characteristics. A report on the pre-press physics blog archive.org claims EPIC 2042-78916 dimmed in brightness by up to 65% over 25 consecutive days, during 79 days of Kepler observations. The authors conclude that the irregular dimmings are caused either by a warped inner disk edge or transiting cometary-like debris orbiting the star in either circular or eccentric orbits, which Kepler is seeing edge on. And they say observing the disk edge on would also explain the lack of infrared flux. Now, speaking of solving mysteries, that mysterious signal detected by Russian astronomers working for SETI, the Search for Extraterrestrial Intelligence, has finally been identified as human rather than alien in origin. The signal, detected back in May 2015 by the Ratan 600 observatory in Russia, appeared to be originating from the direction of the star system HD 164595, which is located about 95 light-years away in the constellation Hercules. The system contains a Sun-like star and at least one planet, a Neptune-sized world, in a close-in 40-day orbit. The signal was detected in the 2.7 microwave band around 11 GHz. There are no known astrophysical sources at these super high-frequency wavelength bands. But it is part of the radio spectrum normally used by the military, and that's the clue. It was suggested that the mysterious signal could well have been a coded military transmission to an orbiting satellite. After additional processing and analysis, astronomers have now been able to confirm that the signal is in all likelihood terrestrial in origin. Mind you, it's not the first time mystery radio signals, which initially appear to be extraterrestrial in origin, turn out having far more mundane origins. For example, in recent years, several signals picked up at the Parkes Radio Telescope in Australia and initially suspected of being mysterious astronomical phenomena known as fast radio bursts, turned out upon further investigation to be nothing more than the microwave oven in the staff kitchen. If there's enough data, astronomers can determine if a signal originated from outside our solar system by seeing if the signal repeats in sidereal time. That's the timescale which astronomers use, and it's based on Earth's rotation rate measured relative to fixed background stars rather than the Sun. The signal's strength can then be used to determine the direction it's coming from, and parallax triangulation can be used to establish the distance to the signal's point of origin. The main feature distinguishing signals produced by a transmitter from those produced by natural processors is their spectral width, in other words, how much room they're taking up on the radio dial. In fact, any signal less than about 300 Hz wide must be, as far as we know, artificially produced. And narrowband signals, perhaps just a few hertz wide or less, are the mark of a purposely built transmitter. In terrestrial radio practice, narrowband signals, often called carriers, pack a lot of energy into a small amount of spectral space, and so they're the easiest type of signal to find for any given power level. Consequently, such narrowband signals are what SETI looks for. Other telltale characteristics include a signal that's completely polarized, or the existence of coded information within the signal. The problem is military radar and telecommunications satellites all produce similar signals. On the other hand, natural cosmic noisemakers such as pulsars, quasars, and the turbulent thin interstellar gas of our own Milky Way galaxy do not make radio signals that are this narrow. In fact, the static from these objects is spread right across the dial. SETI sorts out these confusing signals by comparing the cosmic static being received from one part of the sky with that from another. Africa played centre stage on the morning of September 1st to a spectacular annular solar eclipse, with the moon passing directly in front of the sun, giving the appearance of a ring of fire over the continent for several seconds. The eclipse was annular rather than total because the moon was a bit further away from the Earth and so didn't cover all of the sun's face. The event began at 0613 GMT over the Atlantic Ocean and was visible across much of Central Africa and Madagascar before finally ending over the Indian Ocean. The maximum point of annularity occurred at 0901 GMT, lasting for about 3 minutes and 6 seconds. If you missed it, don't worry, because the next solar eclipse, another annular eclipse by the way, will be on the 26th of February next year, covering Western and Southern Africa, as well as Chile and Argentina and Antarctica. The SpaceX Falcon 9 rocket has exploded on the launch pad at the Cape Canaveral Air Force Base in Florida, destroying a $260 million communications satellite. The blast occurred as the vehicle was undergoing propellant loading in preparation for a static test fire. Vision of the blast showed an anomaly occurring 8 minutes before the test around the lower portion of the Falcon 9's second stage liquid oxygen tank as the rocket sat on the pad at Space Launch Complex 40 in preparation for Saturday's flight. Moments later, a huge orange fireball engulfed the complex, and the rocket's payload fairing, containing the Amos-6 satellite, crashed to the ground. Static fire tests are a crucial step before a rocket's launched. The Amos-6 satellite was being launched for Facebook to increase internet coverage over Africa. The Patrick Air Force Base 45th Space Wing, which operates the Cape Canaveral Air Force Station, says no one was injured in the disaster, although damage to the launch pad still being assessed. Vision of the area following the blast showed the strongback structure at the launch pad badly damaged and twisted. It's unclear how long it will be before SpaceX will be able to begin operations again from the Cape Canaveral launch site. However, they do have a second launch pad at the facility, Space Launch Complex 39A, which is one of the former Space Shuttle and Saturn V Apollo moon rocket launch pads. SpaceX have hired 39A for flying their new Falcon Heavy launch vehicle. This is the second incident involving a Falcon 9 rocket in the past 14 months. On June 28th last year, a Falcon 9 carrying the Dragon CRS-7 cargo ship loaded with supplies for the International Space Station crashed and burned when a strut holding a second stage helium tank failed 139 seconds into the flight. An Ariane 5 rocket has successfully launched 2 telecommunications satellites into orbit from the European Space Agency's Kourou spaceport in French Guiana.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage du Vulcain. Allumage des EAP, décollage. Paramètres bord sont normaux. La trajectoire est nominale.
What a sight. Blazing a trail across the equatorial skies, heading east over the Atlantic. We broke the sound barrier after 48 seconds. We are now supersonic.
Les paramètres bord sont normaux, la trajectoire est nominale.
Everything's going according to plan, he's telling us. And the boosters are doing all the work right now. Those 2 huge rockets on either side of the main stage, they're providing 90% of our thrust. And they're doing exactly what they say on the tin. They are boosting us away from the gravity of the Earth. It takes an awful lot of firepower to do that. They're burning 2 tons of propellant a second each. That's on average what a car uses in a year.
Séparation des étages d'accélération à poudre.
They have burnt their propellant. We don't need them anymore, so we can lose them and jettison them, and we are losing weight. We've lost about 3/4 of our weight in just over 2 minutes. That's the aim of the game. The lighter we are, the faster we go. So we're now burning the main stage. That big tank of cryogenic propellant is powering us up into the sky. It burns for about 9 minutes. Now, altitude 136 kilometres above the Earth. We've gone beyond what's often known as the Kármán line, named after the Hungarian-American aerospace engineer.
La trajectoire est nominale.
Theodor von Karman, who was working in the first half of the last century. And the Karman line is around about 100 kilometres above sea level. That's about 62 miles. It's often thought of as the border with outer space, and that's because at this altitude, the atmosphere is so thin that the air can no longer support flight with wings. So aeroplanes are out, rockets are in. It's where aeronautics ends and astronautics begins.
Paramètres bord sont normaux, le pilotage est calme.
Intelsat has launched 2 satellites already this year from the Guiana Space Centre. Intelsat 29E lifted off in January on board an Ariane 5, and Intelsat 31 was launched in May. That's providing media services over Latin America.
Il reste 3 minutes de propulsion de l'EPC.
He's telling us that we have 3 minutes of propulsion left on the main stage. We're travelling at 4.16 kilometres per second. Per second, ladies and gentlemen, girls and boys, that's extremely fast, and we are going to be going faster. In fact, once you cross the Karman line, you have to travel at the mind-boggling speed of 18,000 miles per hour.
Paramètres bord sont normaux, la trajectoire est nominale. Il reste 2 minutes de propulsion de l'étage principal cryotechnique.
In order to stay up.
Ariane Space mission VA232 carried the Intelsat 33E and the Intelsat 36 into geostationary transfer orbits. The Boeing-built Intelsat 33E was released 28 minutes after launch. Based on the company's Boeing 702MP platform, the 6.6-ton satellite is fitted with 20 C-band and 249 Ku-band transponders, providing coverage across Australia, Europe, the Middle East, Asia and Africa. The Intelsat 36 spacecraft was released 14 minutes later. Built by Space Systems Loral and based on an SSL 1300 bus, the 3.25-ton satellite is equipped with 34 Ku-band and 10 C-band transponders covering Africa and South Asia. Both satellites carry enough fuel for a 15-year service life. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show is also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, this month exploring the mystery of fast radio bursts.